Okay. So, to do proofs, I highly recommend that you use color. If you don't want to, I can't force you, but I really recommend you use the color. And so, look and see, check and see right off the bat, what are you trying to prove in this first example?
Triangle ABC is congruent to triangle ABC.
Okay, so in basic terms, you're trying to prove that two triangles are congruent? Okay, what are the 5 ways that we can prove triangles are congruent? What are the 5 sets we can use? We can use side, side, side. Angle, angle, side, which is the same as side, angle, angle. Angle, side, angle, help me out. Side, angle, side.
Side, side angle.
Side, side angle? Really? We do side, side angle? Really? No, because if you try and do that one backward, do you really want to be writing that on your assignments? I don't think so. And then what's the weird one?
HLR.
That's the HLR. Okay? And that's the one that's technically SSA, but since it only works on right triangles, we just stick with HLR. So anytime you're being asked to prove triangle congruent to triangle, it's got to be one of these 5 paths you take. Those are your only choices. And so what you do then is you start digging around with your givens and seeing which pieces they gave you so that you know which set you can use. So looking at this first guy here, the first thing they give me is that angle ABC is congruent to angle DCB. You should go into the picture and mark those now. So angle ABC, that's this guy, is congruent to angle DCB, that's this guy down here. Okay. That's a set of congruent angles. Which letters do angles get? They get the A. So I have 1A. So are the chances good that I'm going to be doing side, side, side?
No.
No. I might use the angle to tell me something about a side, but for right now, all I have is an angle. And then you look and go, okay, what else did they give me?
Side.
A set of sides. I've got AB is congruent to CD. So I have a set of sides. Oh, I don't have 3 things being congruent. Is this an impossible problem?
No.
No. Nope, it's not. Because
We have an implied statement.
you've learned a crap ton of implied statements. And so a lot of those will give you clues. So what you want to do is start looking for other relationships you see. Like, for example, you might want to look for vertical angles. Do those make congruent angles that you could use?
Yes.
Yeah? What about if you had some parallel lines?
That'd be nice to have.
Could that give you some congruent angles, maybe?
Yeah.
What if I told you a triangle was isosceles? Would that give you anything?
Yes, very much.
It could give you congruent sides, which also implies that you have congruent base angles. Okay, what about if you have a shared part? Like a shared angle or a shared side? Would that be helpful as well? Okay. Well, no, but that one is the reflexive property. Because if both of you have CD, the reflexive property tells you that CD has to be congruent to itself. And that would give you a set of congruent sides. Okay? Diabolical, huh? Okay, so what things do I have here then? I have a shared side.
There it is.
And it's going to be congruent to itself. So I have a side and an angle in another side. But how are they arranged? Because if they're arranged in SSA, I can't use them. So, is my angle between the 2 sides?
Yes.
Is it between the 2 sides over there?
Yes.
So then, yes, I have SAS. Okay? Now, you've already planned your proof. All you have to do now is put all the implied statements down and you're done. So let's start it off. Let's start off with this first guy. Angle ABC was congruent to angle DCB. And how did we know that? It was given. And see how I'm color coding mine by making this match the color I used here? Again, you don't have to do that, but it's something that's very useful to me. Okay? Oh, look! That was my congruent angle. So I have found my angle and I've gotten it into my proof. Because you want to make sure everything's in your proof. What do you want to do next? The other given? Okay. So I can do AB is congruent to CD because it's given. Oh wait, that's a set of congruent sides. I don't need to take that any further. That's just the second thing I needed. I've got that other congruent side there. Oh, how am I going to get this third one in? Yeah, this is one where you could say that CB exists in the picture as a given, but since that one's so stinking obvious, we don't make you put that one as a given. The only time you don't have to start with a given is if you're saying something's congruent to itself, because it's so obvious. So we could say that CB is congruent to CB by what property? That's your reflexive. Which reflexive? That's your POC, your property of congruence. So you don't have to have a given for the reflexive property. Okay, that one you can just start a column with, save everybody trouble. Oh look, that was our third set of congruent sides. And we've already determined in the picture that they are arranged in this order. So what's left to do? I've got 3 puzzle pieces. Put them all together. So if I have all 3 of these pieces, what am I now allowed to say? The triangle is congruent to the triangle. So triangle ABC is congruent to triangle DCB. Oh, but you have to know the implied statement.
It's because
SAS congruent triangles. Good teamwork. Okay? And this is why before you start, it's good to double check that the parts that you have are in the right order. Can you imagine going through all this work and then figuring out that, wait, those are arranged SSA. This doesn't work. I can't do it, and you have to erase everything. That would really suck. That's why pre-planning is very useful. Okay. Yes?
Like, how do you find like a reflexive POC?
I looked in the picture for shared parts. Anytime they both have the same part, you don't have to say CB exists in both of them, and then because it exists in 2 places, it's congruent to itself. The reflexive one, you can start out like you would a given.
Alright, so it just means like you just saw it.
Yeah, I saw it that well, because anything you see is congruent to itself. You're congruent to yourself, as long as you exist. Do you exist? Am I imagining you?
He does not exist.
Am I hallucinating everything? Is this all part of the matrix? Okay. Now that was a level 1 baby proof. Well, the reason why is each box at the top started with your congruent parts. But I'm not always going to give you congruent stuff to start with. And you're going to have to think a little more. So let's go on to the next problem here. What are we trying to find? What are we trying to prove? Congruent triangles. Okay, so I know that I can use one of these 5 things because all I have to do is prove triangles congruent. So let's look and see what junk they gave us. They didn't give me anything congruent because I'm evil and I suck. So what did I give you? I gave you a midpoint. D is the midpoint of AC. Oh wait, what do midpoints imply? Y'all remember the collinear so well. I'm very proud of you. So what will those collinear congruent segments be if D is the midpoint? AD and CD. So I'm going to go ahead and mark them that I know when I put the midpoint into my proof, it's going to lead me to these red congruent segments. That's a useful thing to me. It might not help you, but the colors help me. And that would give me a set of congruent sides. Okay? I don't want to check it off yet because I haven't put it in my proof yet. What am I doing? What else have I been given? I've given a perpendicular. Okay? What do perpendicular things imply? Right angles. So where BD is perpendicular to AD, that's going to give me right angles. Okay? Now that helps me if I want to do HLR. Because for HLR, does it need congruent angles? All it needs is right angles. So if I end up doing HLR, I don't have to say that right angles are congruent. I just have to say that they're right angles and yeet, we're good. Okay? That's why I like HLR. Oh, which part of my triangle is this red one?
The bottom.
It's one of the legs. Okay? So, I might have HLR, because I've got the leg, but what if I don't have HLR? Do these right angles still help me?
Yeah.
Sure.
Yeah, why? Because right angles imply congruent. So those would be congruent to each other, and they could be an angle in like a side angle side thing, or an angle side angle thing. So I don't know which of these I have. I just know that it could be one of these. Okay? Oh, I don't have anything else they gave me. Now you got to start hunting. What's something you can see?
A shared part.
Oh, there's a shared part?
DB.
Oh, DB!
That's on the bottom.
Okay. Which is a side. Oh, but where is that side? Do I have ASS here? Or do I have SAS? I have SAS. So that might be the way I decide to prove it. Let's check HLR. Do I have the hypotenuses being congruent?
No.
Oh, so HLR didn't end up working because I don't have the hypotenuse. This is why you want to kind of just look it over ahead of time. So you don't jump in and say, oh, right angles, I'm going to do HLR. But we didn't have the hypotenuse, so we had to resort to using SAS. Okay? Now that you got it, talk me through it. Start me off. Hey, the givens are the easiest, so if you haven't answered yet and don't want to get picked on, pick one of the easy ones to start off with. Yes, Jack?
D is the midpoint of AC.
Okay, so I'm going to start with D is the midpoint of AC, and that was given. And so, what did that do for me in the picture? That's not congruent stuff. I need congruent stuff.
It's two congruent linear segments.
Okay, but what are they?
Midpoint.
Well, the midpoint is D. What are the segments I can say are congruent? AD is congruent to DC. Okay, remember the top you have to say what's in the picture, and then the bottom is your implied statement. So the bottom will have my midpoint implies two congruent collinear segments. And remember, yes, you can abbreviate the heck out of that. I really need them to move that projector just at least one tile forward. Because it's so blurry, I can't focus it anymore. If it was a little closer, I could adjust the focus a little better. I hate how blurry it is.
Should tell them.
No. I have. You think they've listened so far? Okay. Oh, look! I have a set of congruent sides. Check! That one's been put in the proof now.
I like to check now.
Yeah, me too. That's how I keep from leaving something out that's massively important. You guys don't understand. A lot of the parts of math don't always come naturally. The organization stuff, I have both autism and ADHD. And I have to use these things to help my brain be able to do this stuff. It didn't all come naturally. It's, you help yourself out by doing stuff like this. Which one do we want to do next?
BD.
Oh, the BD. So the BD is perpendicular to AD, which was given. that's not congruent stuff. If I want to do SAS, I need congruent stuff.
It's
Well, right angle.
Oh, the perpendicular tells me that I have right angles, but what are they specifically?
Right angles.
ADB.
Angle ADB, and what's the other one?
is congruent.
No, I'm not saying they're congruent yet.
CDC.
Angle CDB or BDC, that's an angle, are right angles. Because perpendicular lines imply right angles. Okay? Remember, you have to say what you've specifically found and give an implied statement for it. And perpendicular doesn't imply congruent, it implies right angles. And if you were doing HLR, you'd be done there. But alas, we discovered you could not use HLR here, so we must move on. And what do we do now? This green guy, BD, is congruent to BD. This is the special one. You just can put reflexive POC without having to put a given. Okay? And so, oh, that's my other side. And then, oh, this, I don't have a congruent thing for this middle one.
Slow down.
Huh?
Slow down.
Well, I have to now because I didn't do something right. Apparently, I don't have my angles.
I'm confused. What does the reflective
But it's an angle.
what does that connect to from the given?
Well, it doesn't. I'm starting as a new given. Reflexive property can be a new given. Okay? That's the one time you can start with something that doesn't say given, is your reflexive property. And that gives me a set of congruent sides, but I never did find those congruent angles, did I?
No.
No. Have you ever done that when you've been working on a proof and you didn't quite finish the chain and jumped somewhere else?
Yeah.
Yeah, we all do it. It's okay. That's why I like to check stuff off. So I didn't find my congruent angles. Where am I going to find them? Ah, here. These right angles must be congruent to each other. So what will I put? Angle ADB congruent to angle BDC because your right angles imply that they are congruent angles. Now I have finished that chain, which gives me a set of congruent angles, and I can check it off in my plan. Now I have completed my plan. Okay, now it's all there. All the pieces are in place. Now that you have all three pieces, what do you got to do? Huh? Bring them together. So I'm going to go, okay, let's bring this fella down, and let's bring this guy down over here, and let's bring this red fella over. Okay? Well, if I bring side angle side together, what does that give me? The triangles being congruent. Which triangles being congruent?
AD, triangle A.
Triangle ABD is congruent to triangle CBD. Okay? And what's the implied statement?
SAS.
It's not just SAS. SAS implies what?
Right.
Congruent triangles. Got to put the whole thing there. Okay? And so in each one of these proofs, first, go find if you're finding congruent triangles and find your triangles in the picture. Then, start planning. See which pieces you have been given, and then hunt for pieces that will complete one of your sets of three. Sometimes you're going to have to do multiple steps to find one of those things, and that's okay. Number 7 is especially a good one on your homework. And then you bring all the pieces together. Okay?
Oh, there's nothing else.
Never mind, that's almost